Let's delve into the design of a URL shortener system. This is a deep dive into the system design, how the URL shortener should work, and what are the various components that are needed. Consider the example of converting a long URL like https://example com/very/long/path into a short URL like bit.ly/abc123. Before designing any system, understanding the requirements is crucial. Let's start with the functional requirements. Firstly, there should be a URL shortening service. Secondly, the system should handle URL redirection. Thirdly, custom aliases should be an option, and fourthly, links should have an expiration feature. Now, considering the non-functional requirements, the read-to-write ratio should be 100:1. The system should handle 100 million URLs per day. Availability should be at least 99.9%, and redirection latency should be low. Next, let's estimate the system's capacity. The write requests are expected to be 100 million URLs per day, and the read requests are expected to be 10 billion redirects per day. This translates to approximately 1.16 thousand writes per second and 115,000 reads per second. As for storage, assuming each URL record takes 500 bytes and a retention period of 5 years, we would need approximately 91 terabytes of storage. Now let's consider the database schema. The core table, URL mapping table, would include the following columns. Short_URL, which is a variable character with a length of 7 as the primary key. Long_URL, which is of text type and cannot be null. User_ID, which is an integer and can be nullable. Created_at, which is a timestamp and cannot be null. Expires_at, which is a timestamp and can be nullable. Finally, click_count, which is a big integer with a default value of 0. Now let's look at the URL encoding algorithm. We can use base62 encoding. The base62 encode function takes a number as input, uses characters from 0 to 9, lowercase a to z, and uppercase a to uppercase z. While the number is greater than 0, we find the remainder when the number is divided by 62, append the corresponding character to the result, and then integer divide the number by 62. Another method is to use a counter along with base62. The generate short URL function gets the next counter value and encodes it using base62. The result is padded to 7 characters to generate the short code. With base62 and 7 characters, we can generate 3.5 trillion URLs. Now let's outline the system architecture. Incoming requests are distributed by a load balancer to a cluster of application servers. These app servers contain the logic for URL shortening and redirection. The app servers interact with the database for persistent storage and a cache for frequently accessed URLs. Let's discuss the caching strategy. For the cache layer, Redis or Memcached can be used to store hot URLs. The target cache hit ratio is 80% with the LRU eviction policy. The key will be the short URL, and value will be the long URL along with metadata. The cache strategy can follow the cache-aside pattern with a 1-hour TTL for URLs. Popular URLs can also be preloaded. If the URL is not in the cache, it is fetched from the database and then stored in the cache. Finally, let's consider scaling the system. For the database, read replicas can be used for redirection. Sharding by short URL hash can distribute the data. NoSQL databases are used for analytics data. These techniques efficiently handle the 100:1 read-to-write ratio. For global distribution, a content delivery network or CDN can be used for static content. Geographic load balancing and edge caching for hot URLs ensures sub-100 millisecond redirection latency. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.